Okay, right now we're going to deal with translations of a quadratic function. And this particular graph that we're looking at right here is y equals x squared. Sometimes we'll see that in function form. It'll say f of x equals x squared, or g of x equals x squared. And the graph here is pretty accurate. I mean, it's a little bit of human error when I try to draw it. It's a little bit wavy, but you kind of get the picture of it. And what we're going to be dealing with right now are the translations, how this particular graph is going to shift up or down, left or right. So let's look at, first we want to look at what our vertex form of an equation looks like. And here is our equation for the vertex form. And I'm just going to move that over to this side here. Okay, now with this one, the big things that we're going to be concerned with right now are the h and the k. Okay, and what these two letters represent. And h is our horizontal shift. I'm going to go HS, horizontal shift. And that's what direction this graph right here is going to shift, side to side, left or right. K is our vertical shift. I'll just do VS, vertical shift. And that means how much this graph is going to move up or down. Okay, so let's look at an example right now. And we'll go y equals x plus 3 squared minus 2. Okay, so the first thing that we want to do is we want to identify what our h is. And up here, if we'll notice, the vertex form of the equation is x minus something, x minus some number. So this one here, we're going to have to convert this positive to a negative. That way it'll match what we've got up here. So this is going to have to be x minus some number. So if we rewrite that, it would be y equals x minus negative 3 squared minus 2. Okay, now we have this in our vertex form because we've got the negative there. That helps us easily identify what our h is. Okay, and our h in this case would equal a negative 3. Okay, and that's a part that a lot of students get confused on or struggle with. But if you'll just convert everything to the negative first, that will help a little bit. Okay, so we've identified what our h is. Our k is our vertical shift, and k in this case is going to be negative 2. I'm getting that right here. Our k is our last term listed when it's in vertex form. So we'll go k is equal to negative 2. Okay, so now what I'm going to do is I'm going to place another graph here. This one's green, but you'll notice I'll put them right on top of each other. It's the same graph. Okay, and it just kind of helps to illustrate our movement, okay? The y equals x squared, our original graph, is going to be in black, and then this one right here is actually going to be in a green. Okay, so the first thing we want to do is our horizontal shift. H equals negative 3. That means that I'm going to take this green graph and I'm going to move it over, and we want to pay attention to the vertex. Vertex is going to be the easiest way to see the movement. And what's at 0, 0? We're going to take this one, we're going to move it to the left. This one is a negative 3, which means we're going to move it to the left 3 units. 1, 2, 3. So it'll be 3 units to the left. And our k is negative 2. That means we're going to move it down 2 units. So we're going to go 1, 2. We've moved it down 2 units. Okay, so let's go this direction. We went negative 3, h was negative 3, and k was negative 2, so we moved it down 2 units. So this green graph is our new, the new graph, including all of the movements that occurred, all the translations is what we call them. And one neat thing about the vertex form is it quickly identifies what the vertex is. So the vertex is h, k. This is like a little code that we use. And we know what our h is. Our h is negative 3 and our k is negative 2, so now I just have to fill that in. The vertex on this particular one is going to be negative 3, 2. Remember that the vertex is the highest or the lowest point on a parabola. In this case, it's our lowest point. And it says that the vertex is going to be 3, negative 2. If we look right here, that's 3, negative 2. And that is our vertex, so we know that we got the right answer.